All right, so we're entering the world of linear equations. And a linear equation is any equation for which, if we were to graph that equation, we're going to get a straight line on a coordinate plane. And there's many different types of linear equations, but we're going to start off by looking at standard form. Now, standard form is this form which you see right here, and that is ax plus by equals c. Now, in this equation here, we've got x that represents a variable of x. We're used to dealing with x's as variables, and y is also a variable. Now, what the a represents is a coefficient of the variable x, and b represents the coefficient of the variable y, and c is our constant. So if we were going to put some numbers behind this, let's just say that we've got 2x plus 3y equals 6. And so that would be an equation, a linear equation written in standard form. Now, linear equations in standard form do have some rules that they have to go by. One, a, b, and c, all of them have to be integers. Now, they can be positive integers or negative integers, but they have to be integers. And specifically what that means is that if it's written in standard form, there'll be no fractions. Now, as we're going to learn later on, many times we're going to see linear equations in some form other than standard form that will have fractions in it. In fact, it will not be an unusual occurrence at all. But for it to be in standard form, no fractions. Second rule is that a, b, and c all have the greatest common factor of 1. Now, if we look at what I wrote here, well, the factors of 2 are 2 and 1, and the factors of 3 are 3 and 1, and the factors of 6 are 2, 3, and 1. But when I look at all three of those, well, the greatest common factor that they have is this 1. And so that's proper standard form. Now, what if I had an equation like this? Let's see, we had 3x plus 6y equals 9. Well, when I look at that, 3, 6, and 9, they're all divisible by 3. In other words, they all have a common factor of 3. And so to get that in proper standard form, I'm going to divide the entire equation by 3 and reduce that down to x plus 2y equals 3. And when I do that, I then now have this in standard form. And then lastly, a should be positive. So let's see if I've got some room here to put another example. Well, I maybe can put it right down here. Let's say I've got minus 2x plus 3y equals 6. Well, I got a problem here because I got this minus sign out front. But I can take the whole equation and multiply it by minus 1. And if I do, in effect, what I'm going to do is change every sign in the equation. And so that would then give me 2x minus 3y equals minus 6. So I take this equation here, which is close to being written in standard form, except for that minus 2 out front. And then if I multiply it by minus 1, well, then I get it in standard form. Now, the next slide, we're going to look at several equations as to, one, whether or not they are, we can even put them in standard form, whether they are, in fact, the real question is, are they in a linear equation? And then if they are, is there anything that we need to do to put them in standard form? Okay, we want to take a look at a few equations here and see if they are, in fact, linear equations. So let's look at this first one. So here we got y equals 4 minus 3x. Well, I can put this equation in standard form if I add 3x to both sides. And when I do, I can come up with 3x plus y equals 4. And I'm in that standard form of ax plus by equals c. And so that, in fact, is a linear equation. Y equals 4 minus 3x is a linear equation because I can rewrite it as 3x plus y equals 4. Now, let's look at the second one. 6x minus xy equals 4. Well, it might look close to being in standard form, except I've got two variables right here being multiplied together. So I got 6x minus xy. And because of that, no, that is not a linear equation. Nothing I can do about it to make it a linear equation. It's just not going to be a linear equation. Now, let's look at this third one. I've got 1/3 y equals minus 1. Well, you might say, well, where's the x? Well, x could actually equal 0, and if that's the case, it may not be written. But I do have an issue here. I've got a fraction sitting out here. So what can I do to get rid of this fraction to where this could actually be a linear equation? Well, I can multiply both sides of the equation by 3. And when I do, this 1/3 is going to cancel out, right? It's just going to leave me with 1y. Well, I don't have to write the 1 in front of it. Equals, now I'm going to, minus 1 times 3 is going to give me minus 3. And y equals minus 3 is, in fact, a linear equation. Now, again, don't get confused because there's no x with it, because in this case, well, x is 0. And so it's just not written down. It's not expressed for us. But that is, yes, a linear equation. Now, how about this next one here? We got y equals x squared minus 4. Well, if you look right here, I've got an x raised to the power of 2. Everything would appear that I could get this except for this exponent right here. And that means that no, that is not a linear equation because the x is being raised to a power. Now, the same would be true if the y was raised to a power. That also would no longer be a linear equation. So if you see any of the variables raised to a power, any of the variables with an exponent greater than 1, then it is not going to be a linear equation. It's going to be a polynomial or a quadratic or something like that. Something we'll take up later. Now let's look at the third one. Well, we got two problems here. We got x squared equals 2xy. I hope you can recognize what both of those problems are. Here's one. I got this exponent attached to that x. And the second issue I got here is I got x and y, two variables being multiplied together. And so this also is no, it's not a linear equation. Now, I got minus 2x plus 3 equals 4y. Now, this is a linear equation, and we're going to see why in a minute. But if I'm asked to write this in standard form, well, let's see. I'm just going to start here by moving I'm going to move the 3 over here to this side, and I'm going to move the 4 over here. But when I do, I've got to change the signs of both of them. So I'm going to initially have minus 2x minus 4y equals minus 3. So in effect, I'm subtracting 3 from both sides. I'm subtracting 4y from both sides. But it's not in proper standard form because of this minus sign right there. So again, like we did on the previous slide, I am going to multiply everything by minus 1. And when I do, I'm going to end up here with 2x plus 4y equals 3. And yes, this is a linear equation, and now we have put it in standard form. Okay,